Hi friends, this is Denario Research and welcome to the part number 4 of cryptocurrency statistical arbitrage tutorial. In previous videos we have defined major concepts in statistics like stationarity and cointegration. Also we figured out how to find cointegrated pairs. Today we'll use this knowledge to build spread. Spread is a synthetic instrument that we'll use in trading. As you already know, spread is a stationary process, which means we can and we will apply simple statistical methods to find trading signals. Here is the formula of spread. Say we have two cointegrated pairs, x1 and x2. In this case, spread equals to x2 values minus some magic coefficient, as we called it in the first video, multiplied by x1 values. We already have almost everything to calculate the spread. x1 values, x2 values, and the only missing thing is this magic coefficient. In order to calculate it, we'll use linear regression. Linear regression is a very powerful forecasting tool that is widely used in econometrics, machine learning. Also some trading strategies are built on it. In today's video, I will briefly explain how linear regression can help us to find this magic coefficient. Assume we have two time series, x1 and x2. x1 values are on horizontal axis, x2 values are on vertical axis. At every point in time, x1 value has its corresponding x2 value, like A and B. So these blue dots are intersections of x1 and x2 values. The idea of linear regression is to draw a straight line through this set of dots in such a way where distance between dot and line is minimal. This will allow us to forecast x2 values having only x1 values. For instance, say we have x1 value somewhere here, we go to this line and find intersection between x1 and the line and find corresponding x2 value. But how do we know where to draw line? Like this, or like this, or like this, or any other way. You probably remember from your middle school program that line function is mx plus b, where b is intersection with vertical axis and m is slope. Also, this m is our magic coefficient we are looking for. There are several ways to calculate this m coefficient. The first one is to take mean values of x1, multiply them by mean values of x2, then minus mean values of x1 and x2 multiplied, and divide all these by squared mean values of x1 minus mean values of x1 squared. But this method is not very efficient and time-consuming. That is why on practice people use estimators. We'll also use one of them, which is called ordinary least squares method. So how does this estimator work? It draws some random line through these dots and measures distance between every dot and line. Then it squares all distances and calculates sum of them. And then estimator continuously calibrates position of this line until it finds the minimal sum of these squared distances. Now let's see how OLS estimator works on the example. We used it in the previous video. We generated two random walk time series, x1 and x2. Both of them are integrated of order 1, and as we already know, they are cointegrated. So, let's look at the chart. You saw this in the previous video, so I have plotted only first 50 dots, and as you see, these time series move together. Now let's look at their scatter plot. Here it is. On horizontal axis, you may see x1 values, and on vertical axis, you may see corresponding x2 values. Now let's apply ordinary least squares method to find the line that fits these dots. And here is our less regression results. As you see, they contain a lot of information, but frankly we are looking for these two values. The first one is intersection with vertical axis, and the other one is slope, or our magic coefficient we need to calculate spread. Here is how this line looks like on the scatter plot, almost horizontally. Finally, we have everything to build spread: x1, x2 values and coefficient value. So let's use formula we mentioned before to calculate it. So spread equals to x2 values minus coefficient multiplied by x1 values. And here is spread chart. It looks like white noise. Now let's check whether spread is stationary process, and we'll begin with autocorrelation function and parallelogram. As you see on the chart, there are few statistically significant peaks here. But we have to remember that our significance level is 5%, and we should expect 5% of statistically significant peaks due to sampling variation. So let's make another check with augmented Dickey-Fuller test. Here is ADF test output. Test statistics is -21, which is obviously way less than -2.8, and p-value is 0, which is definitely less than 5%. From this test we can make conclusion that spread is stationary process. Having stationary spread, we are ready to calculate z-score, which is something similar to Bollinger Bands, and find trading signals there. In the upcoming videos, we'll use all this theory to build simple trading bot. Instead of randomly generated data, we'll take pairs from Bitfinex exchange, test all of them for cointegration, we'll take two cointegrated pairs, and we'll use ordinary least squares method to build spread. Then the spread will be input for data analyzer, and as data analyzer we'll use z-score method. Also we'll build risk management and order placement models. Thumbs up if you like this video, subscribe to my channel if you want more videos, and leave your questions in the comment section below. Bye!